All right, so on the back of our notes, if we look at example 2, same ideas. We're just going to try one more and make sure we've got it today. So we're going to start the same way. We've got AB, it's going to be our hypotenuse. We're going to go ahead and draw in the right triangle, and where the legs meet, this time we're going to call it Q. So here's my vertical, right? Something like that. Make it a little thicker so hopefully you can see. And then I've got B. Okay, and where those meet, that's going to create the right angle, and that's going to be point Q. All right, we would like to find M, and it's supposed to be located 3/4. We're going to notice that point, 3/4 of the distance from B to A. So we're also noticing this, B to A. So as I'm traveling from B to A, we're going to notice that I would go left and I would go up. All right, so we're going to start it the same way we did on the front. So we're going to count. Again, I'm looking at a diagonal and I want a coordinate. So I'm not doing distance formula. So I'm going to count first. So if I look at my horizontal distance, right, that one should come out to 12, but we'll double check, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So, yep, so that one should be a 12. And then as we look at our vertical distance, that one should come out to a 6. Okay, so again, 1, 2, 3, 4, 5, 6. All right, so I tend to start, I am a creature of habit, so I'm going to start with my x's. So if I look at from B to Q, that particular distance we said was 12. I don't want to travel the whole way. I would like to go 3/4. So I take 3/4 and we're going to multiply that by 12. And that's going to get us a distance of 9. And then we notice that I want to go from B to A. So that's going to be traveling left. So let's make a note. B to A is going to be a left, which is going to be in negative direction. So I'm going to start at B. So I'm going to notice my B coordinate. That one's going to be over here at 7. Looks like -2. So we're going to start at B. The x value is 7. So I'm going to take 7 and I'm going to get rid of 9, and that's going to leave us at a -2. So that should be my new x coordinate, is going to be at -2. I'm going to do the same thing with the other side. So I'm going to do my vertical distance now. So this time A to Q, that vertical distance, that's going to be a 6. I would like 3/4 of 6. And again, we're going to leave that as a fraction. So 3/4 of 6 should come out to 9/2, 4.5. And again, we're going to go from B to A. So we're going to notice that this time, to get from B to A, I would go left and I would go up. And up is a positive direction. So I'm going to start at B. The y value is going to be a -2. And so I'm going to go -2, and I would like to go up 9/2. So again, on those calculators, see if we can get it to look a little better. It's still hard to see, and I do apologize. All right, so we're going to do -2, and I would like to do plus 9/2. 2.5. Again, we're going to encourage you to put it as a fraction. So it's going to be a 5/2. So our new coordinate, which we said was going to be M. So M is going to be at -2, 5/2. All right, so let's see if it even looks like it. So -2, and then 5/2 is 2.5. So it does. So here's M. Okay, and then again, we're going to practice just creating those similar triangles. So now we're going to draw a segment from M that is perpendicular to B to Q. So I'm going to go ahead and drop that perpendicular. And when we say perpendicular, remember that has to hit at a right angle, right? That's how we're creating those similar triangles. So here's my right angle, and where we wanted it to hit, we're just going to call it an H, just so we can talk about triangles. Okay, so our similarity statement. So we're just comparing the little triangle to the big triangle. Again, you can do it either way, but because we want our fraction, do you see that the top number of my fraction is smaller than the bottom? That's how I'm going to know I want to use my little triangle than my big one. If it'd been a 4/3, then I'd go big to little. Okay, so triangle, my little triangle, if I start over here at B and travel to that right angle, I would have B to H to M, and that's going to be similar to B to Q to A. Okay, and then we write our sides, because again, we don't know anything about angles except we've got a right angle. So we're going to talk about sides. So again, first and second position. So BH compared to BQ should be the same as H to M compared to Q to A, which should be the same as B to M compared to B to A. And we're expecting, right, a 3/4. So we're going to go ahead and plug it in. So again, if I check this guy, so B to H, if I count, B to H should be a 1, 2, 3, 4, 5, 6, 7, 8, 9. And we already counted the whole way, so 9/12, which, again, that does reduce down to a 3/2. If we check the vertical, again, so my vertical distance, H to M. Now this one, again, I'm going to have to start, again, it's fractional, so I'm going to start with my 5/2, right, because that's my Y value of the M. So if I take 5/2, and the Y value of my other one, 5/2, and we're going to get rid of, sorry, H, that would be a -2. And that one should come out to a 4.5. Okay, so we've got a 4.5 over a, and then my total here was a 6. And again, if I check that 4.5 divided by 6, that does come out to that 3/4. Now, I appreciate, yes, we could absolutely do the other side, but for the sake of time, right, we're going to go ahead and skip the diagonals. But again, you could run a Pythagorean theorem to prove that those are the same. Idea for today is just being able to write that similarity statement and see how those sides line up. How the sides line up, okay, and that these should match. Okay, so we're going to try one more. This one's just going to be a little bit nastier because it's not going to have, it's not going to divide quite as nicely, but the same ideas. Okay, so I want 1/5 this time, and I'm going to go from A to B. Okay, so one more time. So if I want to go from B to Q, remember that distance was 12. I would like 1/5 of 12, which as a fraction is just going to be a 12/5. All right, so if we want to go from A to B, that would be a right direction and down. Okay, so I'm going to travel right, at least for my x's, which is going to be a positive number, right? I'm going to travel in a positive direction. So I'm going to start at A. My A coordinate, which I have not written yet, that looks like that's going to be at -5, 5. Is it? Nope, -5, 4. I apologize. That should be a 4. Okay, so -5, 4. Let's get that corrected. There we go, -5, 4. Okay, so the x value of my A coordinate is going to be a -5. I'm going to move in a right direction, so I start at -5, and I'm going to add 12/5. Okay, so again, on your calculators, we've got a -5 plus 12/5, which is going to be a -2.6, excuse me, which as a fraction, -13/5. And then we're going to do the same thing in the y direction. So same idea. So A to Q, that one's going to be a 6. We'd like 1/5 of 6, and that's going to get us a 6/5. So again, we're going to go A to B, but this time I'm looking at my y's. So from A to B, we're going to go down, which is going to be a negative direction. So I start at A. That's going to be a 4. And we're going to get rid of 6/5. Okay, so 4 minus 6/5 is a 2.8, which as a fraction is a 14/5. All right, so point N, that's what we're supposed to be finding. So N is going to be at -13/5, positive 14/5. Okay, so give or take, right? So the decimal put us at -2.6, so somewhere here-ish, and then positive, so again, here's right up here, give or take. Okay, that's where N should wind up. All right, so if we do our similarity statement again, so again, let's drop a perpendicular. And we're supposed to call that W. Okay, so our statement, again, it's getting hard to see all of it, but here we go. So triangle, I'm going to start over here at B and go to right angle and up. So B to H to M should be this similar to triangle B to Q to A. And as soon as I wrote that, I saw I did the wrong one. I want to go to W, not H. That was our last one, so let's try that again. We want the correct triangle. Here we go. B to W to, oh, I did that wrong too. B to W to N. Let's try again. Let's get the right triangle. There we go. And then B to Q to A. That's okay. All right, so our statement of proportionality, right? So I would have BW over BQ is going to be the same as WN over QA, which is going to be the same as B to N over B to A. Okay, and then if we check those values, right, they should all come out to the 1/5. Now, what we're going to notice, though, is that it's not, right? We're going to find a diagonal, and the diagonal is here. So we're going to notice that the diagonal is on the larger portion. So though it is absolutely supposed to be a 1/5, because of the orientation of our triangle, it should come out to a 4/5. So again, if we check one of the nicer sides, and again, they were all fractional this time. So again, if I want to try, let's just do this BW one. So if we look from B to W, the X value of W is going to be way over here at over here, the X value should match up with it. So negative 13/5. So if we take negative 13/5, right, and I would like to find the difference. So back over to this value, over here, that should be a 7. So negative 13/5 minus a 7. 9.6. So our distance there is going to be a 9.6. Right, distance is always positive. Right, so when I start over here, all right, and then if I look at the whole distance, that should be over a 12. So if I take the again, let's do positive, 9.6 divided by 12, change it to a fraction, that does give us a 4/5, which is what we were expecting. Again, we were finding the hypotenuse, right? But we were asked to travel that little piece in between. So again, if this side is 4/5, I would hope that it would make sense that the other side would be a 1/5. Okay, and so even though it came out just a little bit, you know, we found the other piece, that again, the idea of a complement, it's the other piece of it. Okay, so that leads us into our very last idea today, which is about the idea of a ratio. So if I just use this one right here, we can talk about the ratio of A to N, right, compared to, so if I want the ratio of A to N compared to N to B, okay, what A to N would be a 1/5, right, and that's comparing it to a 4/5. Now, I appreciate that when we write it in this notation, it's a little, you know, you can leave it as a fraction. Remember that ratios can be written with the colon, or I can write them using that fraction bar. So I can have a 1/5 compared to 4/5. Now, what I would hope we could remember, and I appreciate it might be a stretch this morning, right, that if I went ahead and reduced that because my denominators were the same, it ends up coming out to a 1/4. So my ratio is 1/4. If I add them, right, that's where I'm going to get back to. There were originally 5 pieces, but my ratio was just looking at those numerators, right, that there was 1 piece of the 5 compared to 4 pieces of 5 on the bottom. That was the idea. So we're going to use that then on this last one. Instead of having to draw a brand new picture and all that good stuff, we're supposed to find E in such a way that the ratio of the measure of the segment AE to EB is 1/3. Okay, so we're just going to draw it. So if I have A to B, right, A was up here and B was down here, I'm going to throw E on there. Now I'm noticing that A to E is smaller, so I'm going to throw it up here. But the idea is that this is 1 piece and this is 3 pieces. Okay, so I have 1 piece compared to 3 pieces, which means if I divide this guy up, that when I look at the whole segment, there are really 4 total pieces. Okay, so if I want to find point E in such a way that the ratio becomes this, what it's really asking me to do, right, is find a quarter of the way. And I would like to travel from A to B. That's what it's really asking. Okay. Now, if we notice, we've already done this work, right? So if you look back up in 2A, we were finding M so that it was 3/4 of the way, right, from B to A. So we've already done this work. So I don't know that we need to do it again. But that's what it's really asking. For those of you that have got it, absolutely you can go ahead and get started. But for those of us, if you want to see it one more time, I'm absolutely happy to do that. So if I'm traveling from B to A, right, what I'm going to notice, again, I'm going to do my horizontals first. So B to Q is going to be a 12. I would like 1/4 of 12, which is going to get me a 3. If I'm going from A to B, I'm going to travel in a right direction, which is positive. So if I start at A, A's coordinate was going to be a -5. Right? So I start at A, I'm going to have -5, and we're going to add 3 to that, and there's your -2, which is what I'm expecting, right? Because it should be the same coordinate that we found in A. If I do the same thing again, so this time if I look at from A to Q, or Q to A, either way, A to Q, that one's going to come out to 6. I would like 1/4 of 6. Right, so here's your 6/4, which is really going to be a 3/2. And again, I'm going to travel down, which is a negative. So I'm going to start at my A. The Y value should have been a 4. And we're going to go down 3/2. And that should come out to that 2.5, which again was a 5/2. Okay, so E should be at -2, 5/2, which again, we already should have known because we found, I think it was M from up above, M was 3/4 of the way from B to A. So I would really hope that if I go 1/4 from A to B, it would be the same thing, which it is. Okay, so for tonight, that's what you're going to try and do. Again, watch the video as many times as you need to kind of help you through it, but that's our idea, and then we can clean that up tomorrow. So I hope you have a great rest of your day, guys, and I appreciate your patience. Thanks so much.